Hello everyone, you're watching lesson video 6.3, completing the square. This is something that you've never done before, and I hope that you get really good at it by the end of this video. We're going to talk about shifted form, vertex form from yesterday's notes. So when you look at something that's written in that form, vertex form, you should be able to tell me where the turning point or vertex is. And you should be able to determine the range. So if you're thinking about the original parent graph, x squared, and the vertex being at 0, 0, you can see that this one shifted 3 to the right and up 2, which made the vertex go from 0, 0 to 3, 2. And the range, if you plot the point 3, 2, you can see is everything greater than or equal to 2, or 2, infinity. So it's really nice to have something written in that form. If it was written in the other form, standard form, how do you change it from that form into shifted form? And that's the process that we're going to look at called completing the square. So I want you to take a minute and do exercise 2 and turn these all into trinomials. In other words, simplify, or you should be thinking, use the box method, otherwise known as double distributing. Stop the video and do that now. And then turn the video back on and check these answers. I have x squared plus 10x plus 25. So if you look at the form, b is 10, c is 25. I'm looking at the b and the c from the trinomial form, from standard form. Here b is -2 and c is 1. And here b should be 8 and c should be 16. Question 3, or exercise 3, asks us to note the comparison between the values of b and c. So you could stop the video and think about that question for a few minutes. And then I'm going to tell you what it is, because it's more fun just to hear answers from people than it is to do all the thinking on your own. Just kidding. Okay, so let's look at b to c in the first example. 10 to 25. How did I get from 10 to 25? Well, I took half of this number, 5 and 5, and then I squared that number. In other words, 5 times 5 to get the 25. All right, look at example B. I'm looking at the -2 from here and the 1. If I take half of this number and split it into 2 equal pieces, -1 and -1, and then I multiplied them together, or squared -1 to get the 1. So again, I took half of b and I squared it, and I got c. Let's look at that again. In the third example, I have an 8 and a 16. How does 8 become a 16? If I take half of it, 4 and 4, and I square that, I then get 16. So the relationship in a nutshell, I'm going to write that in this little box here, is to take, well, I guess I'm going to erase that because I don't know what I was thinking with that mark. The relationship is take half of b and then square it, and that will give you the value of c. Take half of the b value, square it to get c. Okay, so each of these examples you're looking at is a perfect square trinomial. You can note that because you end with a perfect square. 100 was 10 squared, 9 was 3 squared, and 1 was 1 squared. If you end with a perfect square and you also have a number in the middle that forms this relationship, you can do this. So let's look at the pattern that we just considered. If we were to look at this as taking half of 20, so this is, oh, my hand keeps hitting that thing, x and x, 10 and 10, is taking half of the 20, get 10 and 10, and then squaring that, because if I did 10 times 10, I'd get 100. This factors perfectly into x plus 10 squared. That's what we're looking to do here, to factor these into perfect squares. So x and x, that makes my x squared. Take half of the -6, -3 and -3. So just think about splitting that into the same number twice by dividing by 2. That's half, right? Half is dividing by 2. And then you notice the -3 and the -3 would make the 9 if you multiplied it back out. So this is x minus 3 squared. The reason I'm writing it as a square is you have the same factor twice. X minus 3 times x minus 3 is a square. How about this one? See if you can think about this before I complete it. I'll start with the x and the x. Think about the number that would go here. 2 split in half is a 1. Everything was positive here, so I don't need a -1, I need a +1. And that 1 times 1 at the ends would make the 1 at the end. Again, if it helps, you could also use the box method to think about this. How am I going to get an x squared? How am I going to get a 1? Think about what you need. This is x plus 1 squared. So these perfect square trinomials are like the ones we had back up in exercise 2. We wrote them as perfect squares, factored form. It's going to get a little harder on the next page. So finally, you're ready to learn the method of completing the square. Completing the square. So these are steps. You're going to rewrite the equation so that you pull the constant to the side. You're going to find the number that creates the perfect square. You're going to add it and subtract it. Well, you're going to have to square it, and then add it and subtract it. And then you're going to write it as a completed square and combine the constants. This finally will end up, oops, I hit that again. This will end up in vertex form. So if you get lost, you can read the steps. So if you look at the example, I'll run through it real quick. Here's our example. We're going to take the 23 and just push it aside because he's not a perfect square. We're going to try to make him be perfect, but he's not right now. So avoid him. He's not very helpful. Move him to the side. Create a space. Think about b. In this case, my b value is -10. Take half of it. That's where this -5 is coming from. So I took half of -10. I got my -5. Then square that, and there's a 25 that I need to put in to create this perfect square. So it's like you're putting a 25 right in here, but if you add in 25, you also need to take that away so that you are just really adding in a 0 and not affecting the equation. Then you have this perfect square, x minus 5x minus 5, which is a square, and then you're just adding -25 and 23 to make the -2. We're going to do a bunch of these, and you're going to get really good at them. So if you look at this quadratic, this is standard form. We're going to try to get the function in its equivalent shifted form, otherwise known as vertex form. Then we can see where the vertex is. I believe it should be at 2, -1, 2, 3, 4, 5, according to the graph of y equals x squared minus 4x minus 1. So we should be able to compare with graphing. So let's look at our function, x squared minus 4x. We're going to move the -1, leaving a space. We're going to think about splitting our b. Remember, we're trying to take half of the b value, the number that's sitting in front of the x. Take half of that. So we have, if I started to think about what this would be as factors, a -2 and a -2. Which means if I squared that, I would get a +4. If I add 4 into this side of the equation, I need to take 4 away. So these are going to be combined into a -5. So I did take half of b and I squared it. I took half of -4, that was -2. I squared it, and that was the 4 that I needed to add in to the blank spot and take it away. When I write this as a perfect square, I get x minus 2 squared minus 5, and you should notice that the vertex is at 2, negative 5. Let's do that again. Y equals x squared plus 6x blank minus 2. Move that away a little bit. Take half of 6, 3 and 3, or 3x and, well, I don't want to say that. Never mind. Just 3 and 3. Take half of b is 3 and 3. So it's going to look like x and x to make your x squared right there. 3 and 3. Everything was positive on the 6. You get a positive 3 and a positive 3. That creates a 9 that I needed to add in to the blank spot. Adding in a 9, and then I need to take off the 9, and negative 2 take away 9 is negative 11. Everybody always forgets to take the 9 off, and then that number would be wrong right there. So writing it as a perfect square, I hit that darn thing at the bottom again. Y equals x plus 3 squared minus 11. Once you do that, you should be able to identify the turning point because the directions ask you to. I lost my parenthesis. My turning point should be at, I'll call it the TP for toilet paper. My turning point should be at negative 3, negative 11. And if you graph it, you will see that. Let's do another one. Y equals x squared minus 2x plus blank plus 11. Y equals, I'm trying to factor this thing with the blank, ignoring the 11 for now. So that blank needs to be, take half of b minus 1 minus 1. So I got my x squared, I got my minus 1 and minus 1 to make my minus 2. And if I multiplied negative 1 times negative 1, I would have a positive 1. Add 1 also, oh, nope, I almost messed that up. I added 1 in, so I need to not add another 1 in. I got to offset that plus 1, so I need to take away 1. Because positive 1, take away 1, gives me a 0, and I didn't change the value of anything. So this would be a positive 10 at the end. All right, so that gives me my perfect square of x minus 1 squared. Those two factors are exactly the same, not a plus and a minus, exactly the same, plus 10. And my TP is 1, positive 10. If you think of the shift that helps, you went 1 to the right and up 10, so 110. This one was 3 to the left and down 11, negative 3, negative 11. All right, let's do another one. You got y equals x squared minus 10x plus the blank when I move the 27 over. So we got to fill that blank. So y equals, I start writing parentheses to get my factors, and I know I got x times x to make my x squared. This is going to be split in half. Negative 10 split in half is negative 5 and negative 5. Multiply those two together. 25 is my number I need to make a perfect square. But if I add in a 25, I also need to take off a 25. So this number at the end is a positive 2. 27 take away 25 is 2. Final equation as a perfect square in vertex form is x minus 5 squared, that's the same factor twice, plus 2. Vertex then looks like a shift of TP, looks like a shift of 5 to the right and 2 up, so my turning point is 5, 2. Okay, this next one is a little bit weird because the constant is a 0. So all I really need to worry about are these two things. Oh, I just hit that thing at the bottom again. Well, let's go over here. I got y equals, I'm going to start looking at my factors already because there's no blank there. There's no constant to worry about. It's just going to be x and x plus 4 plus 4. So I'm splitting the 8 in half. Squaring that is 4 squared. 16 is my number I needed to add in. So I'm adding 16 to nothing, which means I needed to take 16 away. Take away 16. So this is x plus 4 squared, take off 16. See, the reason you're adding it in and taking it away is you don't want to change the value of what you started with. So by putting in this 4, 4, 16, I need to offset it and take it away. My vertex then would be -4, -16. Turning point vertex. All right, this one is back to normal. You got x squared and, oh, 5x is a little weird. You'll see why in a second. And plus 4, I'm just shifting over. So I made my blank, and I got to take half of 5. Well, if you don't like taking half of 5, you really should, because it's a piece of cake. X and x, taking half of my 5, is just going to be 5 halves. Look at how easy that was, 5 halves. I know you hate fractions, whatever, get over it. Okay, so you got plus and plus. Now this number is going to create my perfect square. So multiply the 5s, 25. Multiply the 2s, 4. So if I add in 25 over 4, I got to take off 25 over 4. This is y equals x plus 5 halves as a square. Do this on your calculator and tell me what you get.